Thank you, Adarsh. That was really insightful, and Adarsh set me up for this talk because to do environment as code, we need to do infrastructure as code first. And when Adarsh started talking, he said, "Hey, folks, I assume you know what Terraform is, what Pulumi is, and we are going to go one level low, basic, to talk about infrastructure as code tools today." A little bit about me. Hi, I'm Kavitha. I'm an engineering manager in Microsoft. I lead a team of 6 engineers in commercial software engineering. Commercial software engineering is an engineering organization where we work directly with biggest companies and nonprofits to help solve their complex technical challenges with latest Azure cloud technologies. Personally, a little bit more about me. I live in New Jersey with my husband and 2 handsome boys. And in my spare time, I would love to build Legos with my kids. Agenda today, we're going to talk quickly about why use IAC and go through 4 different tools and some factors that I would consider to when you pick one tool over the other, and a quick demo of how we can deploy an Azure resource group using all 4 of these. I work in Azure in and out, so all my examples today are in Azure, but the concept are the same. Now, why use infrastructure as code? It's super easy to deploy resources manually in any cloud. In Azure, I can just go to the portal, create any resource in a few clicks. For example, I can have the full Kubernetes cluster up and running in no time. But what happens when I have to create multiple of these? Now I have to remember what exactly I did. I picked standard cluster, this version, and everything else, and that's just the first tab. And we have much more. And for the application these days, you have to create a lot more infrastructure. And that's where infrastructure as code comes in, where you can automate the entire stuff like others talked about. It's code, so you can put it in the repository, do the PR workflow, add validation, testing, and security scanning, everything in the pipeline, and automate it end to end and take it to the next level. And finally, it serves as an automatic documentation. If I have to look into what's in an environment, all I have to do is look at my code. Now, let's talk about our first tool, ARM template. ARM is how Azure deploys resources. Azure is built on top of ARM, which is Azure Resource Manager. It's super powerful. It's Azure's native construct. You get day 0 support with ARM, meaning the day a new Azure resource becomes available, you can deploy with ARM template. And it's written in JSON. All of us know, JSON is very machine friendly and not really human friendly. It's not very readable, maintainable, and it's hard to reuse. There is a concept of nested template and linked template. It's still really hard. That is an example of ARM template to deploy an Azure resource group. As you see, it's super hard to read. And there is something super cool I want to really quickly go over. If I have no idea what infrastructure as code is, I've always been creating resources manually on the portal. You can go to the portal, create any resource. In this case, I'm creating a resource group. And before I click create, I can click on download the template for automation. And that way you can get any resource in Azure, the JSON template, take it, modify it, and put it in a repository. Now to summarize, ARM template is written in JSON. It's not so easy to write. You can only use it on Azure, and there is still a large user community, and you get day 0 support. The next tool we are going to look at is Bicep. Bicep is nothing but syntactic sugarcoat sprinkled on top of ARM. Now, what I mean by syntactic sugarcoat is that under the hood, Bicep just uses ARM. It just gets converted into ARM template, use the same ARM APIs, and deploys resources. Bicep can be conceptually, it's like a wrapper on top of ARM template with much cleaner syntax. And Bicep can be converted into ARM as well as vice versa. Now that's an example of the same Azure Resource Group code in Bicep. Like you see, it's much more concise, and compared to the ARM template, more modular, easy to read code compared to the ARM template. Now we have a concept of Bicep modules, which makes it easier to write modularized code. In Bicep modules, you can write any Bicep code. Say in this case, resources.bicep can be used in another file and reference it as a module. Now, let's take a pause and see why do we want to write modularized reusable code. One of our customers has a very strict security requirement where they have a, for example, set of corporate IP addresses which needs to be whitelisted. So we were able to write that as a module, create a policy or a firewall rule, and use it in all other resources, like all the storage accounts need to be whitelisted. So with modules, we are able to create this magical compliance network with ease and maintainability. So the next thing we are going to see is there is a what if command option that's available in both ARM template as well as Bicep. If you had used Terraform, this is very similar to Terraform plan. This was only publicly available at the end of 2020. So what it provides us is before we run or create or modify any infrastructure, if we run a what if command, it gives us exactly what it is going to modify. You can preview the changes before it applies. Now to summarize, you get day 0 support with Bicep as well. It's much easier to write, reusable and maintainable. It's only available for Azure Cloud, and we had a small user community. They are growing now. If you haven't started writing any code, and if you're thinking about ARM template plus Bicep, we highly recommend starting with the Bicep code. And there are a lot of our customers who have migrated from ARM template to Bicep and super happy with the simpler syntax. And the language is Bicep. Now the third tool we are going to look up is Terraform. Terraform is built by HashiCorp. It uses its own language. Similar to Bicep, you get all the parameters, variables, and modules, and all the good stuff. This is the first tool today we are talking about for which can be used for multi-cloud. It supports all the major cloud providers. With Terraform, you can provision, apply, and destroy resources. We haven't seen a destroy in ARM template or Bicep. That's because it doesn't have one. We have a concept of a scope in terms of Bicep and ARM. If once we create those resources, you need to clean up the resource group or a subscription. But in terms of Terraform, we have a destroy command which lets us clean up the resources, cleanly clean up the resources. Now, that's an example for the same Azure Resource Group deployment in Terraform. Now, we said Terraform is multi-cloud. That doesn't mean that the same code that we write in Terraform for Azure can be used in AWS or any other cloud. The code is going to look entirely different. It only means that you can have a common language across all the clouds when we use Terraform. Now, we did talk quickly about Terraform plan when we went through the what if. So Terraform plan tells us exactly what the change is going to be applied. This case, in this example, there is one resource that's going to be added, which is the virtual network. Now, Terraform, when in case of ARM template or Bicep, how they compare the incoming code and find the change is they really look into the Azure cloud and find out what is there and do the comparison. But in terms of Terraform, Terraform maintains a state file to keep track of all the resources it provisioned. And it could be a local, there are two options with the state file. It could be local or remote. Local is going to be stored in the local computer. For remote, all the major cloud providers have their own, provide a lot of options. Now, state file is plain text file, and it might contain secrets. So we need to make sure it's stored securely, encrypted, and everything else. We're not going to go into the best practices. There are a lot of articles in each cloud how you can securely store the state file. But all we need to know to do the comparison is like there is an additional administrative effort that's needed to make sure to store the state file. Now, the final checklist, Terraform doesn't used to provide a day zero support, at least in terms of Azure. Now, we have an AZ API provider for Terraform. They have a link in the reference if you would like to check it out. This recently came out, so we do have a day zero support with Terraform now. I'm not sure about other cloud providers. It's super easy to write. There is an additional state file administration that you want to think about. It is multi-cloud, and there is a huge community of users, and the language is HCL. Now, the fourth tool that we are going to quickly talk about is Pulumi. If Terraform is the most popular kid on the block in IAC world, Pulumi is the new cool kid that's coming up in IAC world. Pulumi is also multi-cloud. On top of supporting all the cloud providers, it can also manage users in Postgres, SQL, MySQL, as well as namespaces in containers like Kubernetes. The super cool thing about Pulumi, though, is you can write it in all these full-fledged programming languages like C#, Python, TypeScript, JavaScript, and Go. What gives us that you can use your favorite IDE. If the application developers are already using these languages, it's super easy for them to start writing IAC code. It also gives us an unified agile development process if it can follow the same process as your application code. And in terms of testing and validation, we saw how the ephemeral environment works. You can tear up and tear down. In those cases, you can use your unit tests, functional tests, and integration tests all in the same way that you write for application code, since it's a full-fledged programming language. Bicep doesn't have like a great testing framework yet, and Terraform can probably write integration tests with TerraTest and other tools. But with Pulumi, you can do code validation and testing just like your application. And Pulumi also provisions, updates, and destroys infrastructure, very similar to Terraform. It also uses a state file to track all those resources that it provisioned. But this case, this state file is encrypted at rest as well as in transit. So they have a more robust state file management in terms of Pulumi, which automatically comes with the tool. And for the password, they support all major cloud providers like Azure Key Vault, AWS KMS. So it has more additional support that we thought through this before. Now, that's a sample C# Pulumi code. Like I said, you can write this in TypeScript, Go, or any other language. And similar to Terraform, this code is going to look entirely different if you're writing for other clouds. And for example, this Azure resource group, if you see the way it's written, it's just creating an object for this class. And that's super simple. Of course, you can add more parameters, but for an application developer who has never written an IAC code, I think this is super easy for them to start working with. And the final checklist, you don't get D0 support with Pulumi because somebody need to write the underlying providers, how it interacts with the clouds. It's very easy to write. If your developers are working with those languages, it's easy for them. There is also a state file in case of Pulumi, and it is multi-cloud, as well as you can maintain Kubernetes and users in MySQL. There is a small community right now, but it's gaining popularity as we speak. And all those are the languages that you can write Pulumi code with. Now, let's take about some of the factors now that we have seen all 4 tools. How do you decide one tool over the other? Now, if we need any open source tooling, like linting, compliance check, security scanning, and testing, the tool like Terraform has more of open source tools to help, like TerraTest for testing, TFLint for linting, and security scanning and everything else. So Bicep may not be a great place to start with. And if you need day 0 support, you're using latest preview GA products with your cloud providers, then you might want to look at something that's cloud native rather than Terraform or Pulumi. The third thing is, like, if you have an existing standard in the company that the rest of the company is, using ARM template, or you have an existing skill set that I've never started IAC, but my application engineers already know TypeScript. That's something I want to think about. And the next one is, do we really want to have that administrative overhead of state file? If it's a big deal, then probably not Terraform may not be a great choice. And do you need to deploy to on-prem, cloud, and hybrid environment? Do I have a multi-cloud? Do I want to use a common language across all those? How do my DevOps work? How do I want to put this in CI/CD? All those things we would like to consider. And if I have a multi-cloud environment, I want to use the same language, definitely Bicep is not going to work. Now, finally, am I starting with greenfield or brownfield? If it is, if I have an existing infrastructure already and I want to script it out, at least for Azure, we have like a couple of options. We have an AZ group export where you can point to a resource group and you get an ARM template. You can convert that to Bicep, of course. Or if you're using Terraform in Azure, there is an open source tool that some of my colleagues wrote. It is in the reference call. It's called AZ Terrafy, where you can point to a resource group and you get the Terraform configuration file. Terraform does have an import, but you need to still manually write the configuration style, so configuration file. So they came up with this open source tool. I'm sure the other cloud providers will have some open source if you already have an existing infrastructure and you would like to move to infrastructure as code. Now with that, I'm going to quickly go over a little bit of code as well as a recorded demo in the interest of time. All right, we can quickly go over some code and do a quick demo before I wrap up. So that's my simple ARM template for deploying a resource group as well as a storage account. We have 3 parameters here, resource group name and storage account. And here is how lengthy the code is. And we also have something called depends on here because we want the resource group to be created first before we create the storage account. And to compare that with our Bicep modules, this code is like, it starts with the subscription scope. It creates the resource group here. And then this one is for the storage account. And the code is super modular. It's calling a module called storage Bicep. And the depends on, if you see here, compared to the ARM template, is much more readable and simple. And that's our quick storage account code. Again, compared to ARM template in a single huge file. This is a much modular code. And let's quickly look at Terraform, how it would look like. It's very similar to Bicep. It's going to use an Azure ARM resource provider, and that's our resource group code and the storage account code. And if we have to look at the same code in Pulumi, like we talked about, these are all written in classes, and you're just creating an object for both the resource group as well as the storage account. Thank you. Sorry about that. So we're going to quickly talk about how an ARM template and Bicep, they both can be deployed using the same AZ CLI commands. Here we have AZ deployment. I'm using a confirm, which is similar to the what if command we talked about, and the same ARM template we saw. And that's taking a few seconds. And it gave me an option, gave me exactly what it is going to deploy, which is a resource group as well as a storage account, and it's asking for a confirmation. And it already created those two resources. One is the resource group, one is the storage account. And in terms of Terraform, we use a Terraform init to get all the providers up, and then the Terraform plan, similarly we talked about. And again, it's going to ask, it's going to give me the details of what it is going to create. And to apply the changes, I have Terraform apply, which is going to ask for confirmation again for those two things it's creating. And once it's giving me a nice little update of, here I'm creating this is the percentage, and then it's done right now. So my storage account as well as resource group is up, and it's nice and easy to clean up. All I have to do is Terraform destroy to clean up those two resource groups, those two resources. So it has two resources that it's going to destroy. It's telling me exactly what it's doing, and it's done. And in terms of Pulumi, similar to Terraform, we have the Pulumi preview. When I got into Pulumi preview, it's giving me three different options of environment. Here you can create any environment, and then for the state file passcode, I am using local, so I gave a passcode to encrypt this particular state file. So in terms of Terraform, you can also write into different environments, but Pulumi gives an very nice option to add it right here with what environment. If for different environments, it uses different state file as well as different passcode. So now I have the passcode, and then similar to Terraform plan and the what if command, it's going to give me the changes it's going to do before it applies. There are three things it's creating. One is the stack itself, one is the resource group, one is the storage account. And to make it work, similar to apply, I have Pulumi up, and it's asking for the environment again and the passcode, and now it's giving me a clean, here is the two things I'm going to do, and it's done. And finally, we have for cleaning up the resources, we have Pulumi destroy, which we saw. And one nice thing about Pulumi is that when you see the resource group here, it has created when I wrote the code, I only said yes, name the storage account as SA. But when it created the storage account, it added a random value and created the storage account, which is super cool, which needs additional work in Terraform or something else where you need to create your own random variable. but Pulumi has an option of if by default it adds a random value on top of the name of the resource. And that's all we have today. Any questions?
Yeah, I guess I'm not from Pulumi. I'm not the authoritative source, but I believe they have an Azure native package which provides 0-day support. So I'm not sure if you knew that, but the question is, meaning I know Microsoft has done great work with Power Automate for low code for business applications. What is your point of view for infrastructure automation with low code?
With which one?
With infrastructure automation, are there any low code tools in the market?
No, I'm not sure. I'll have to get back to you.
Do you have, what's your point of view? Is low code the next big thing, or the next cool kid on the block? Or
with the low code, even with Power Automate, I think we target more for folks like engineers. It's not generally for engineers, right? We want to quickly put together something, as well as on a POC, as well as for someone who is not have a full-fledged engineering team, they can bring any app live. But with the IAC, I'm not familiar with the low-code tools yet. But I believe full-fledged IAC code would be for the application engineers and the infrastructure engineers, and the low-key code, in my opinion, would serve someone who is coming up, someone who really wants to put together something faster. With all the environment as code and policy as code and everything as code, when we automate, these are getting really complex infrastructure. And I don't know how far we can get those with the low-code tools. Of course, there will be low-code tools, but then the target audience, I believe, would be different. Similar to Power Platforms. Thank you.